Hi Ben, so I'm going to make short video with your comments, my comments, so I'm going just talk a little bit about slides I sent to you, and it's pretty straightforward. I understood it's what I expected. So we do know stress, it's force divided by area, and at the same time model it's stress divided by strain. And as a result, it's what we actually did in your lectures. EA, it's equal load divided by strain. And then definitely load at specific location of the strain is going to be EA multiply E. So in actually, it's what you did. I took your table, this table, from your Excel file, and you get like one chart if you just using load divided by strain, and another if you take differences between two load on the pile head, so it's delta sigma, and at the same time you have some delta strain, so and you get delta I'm sorry, not stress, it's load. So delta Q, just my mistake. Delta Q divide by delta. From my perspective, you ask me, for me, Q, it's almost the same, if everything fine, delta Q, delta strain. And I understand, because this one high error, because it's already differentiation, it's totally fine. But from my perspective, this value actually, based on my previous slide, is like EA, stiffness. Okay? The same happening actually when you did this one. It just differences. This one concrete piles, it's like steel piles, so it's the same stuff. Actually, intersection with y-axis, this value is our EA, and this one EA, and the same, it's here, EA, EA. From my perspective, it's just QA, QC. So I just would like to make sure, that means if I get similar, so I'm totally fine. I understood from you, that means if my ES and T different, then I need to use AT. But it's already kind of, I understand it's subjective. If it's close enough, I can make average or play around with this stuff. The only thing what I didn't understand, if I'm just taking from Excel file your tab called pile C2HD, and what I didn't understand, this one. So you have something like that. Where did you take this E? I understand, and then actually in your case you 3 multiply by I'm sorry, your 1888 multiply by area, and you got approximately 3, and it's what you told. Okay, so in this specific case, I can use EA like 3 instead of like 3.6 or 3. I didn't understand where did you pick up models. Okay, and the last not least, actually I just would like to, it's what I just told you, we discussed it previously from your presentation. So you have this presentation, and what I told you, actually this, oops, sorry, this chart, it's exactly the same charts what you're showing here, 1 and 2, and you have ESA and this one, and you have ATA with slope double. You see, you have here 0 0.0007, 0 0.014, so double. So, and for that reason, I asked you in previously, so here you called it stiffness. Why did you call it force? It's stiffness. It's what I talked about in your presentation. That's it. So I'm going to download it on YouTube and send you link. Thank you.